In section 2.5, we're going to be looking at what's called one-sided limits. And so you're really going to need to think almost like a plane landing. It's coming in on the runway from either the east or the west. And so that's kind of how I think about one-sided limits, as x approaching from the right or from the left. All right, so we're going to talk about that, and we're also going to talk about continuity. But let's talk about those one-sided limits. All right, we have some different kind of notation. So on these first graphs, we are asked to find the limit as x approaches a from the right-hand side. That's what that little plus sign means of f of x. Then we're asked to find the limit as x approaches a from the left-hand side. That's what the negative means. And then we're asked to find the limit as x approaches just a, which is what we did in the previous section. And so we have to look at the right and the left. All right, so on this problem, and again, these are just copied out of the book from page 126, like problems 1 through 8. I think I copied the odd ones. All right, so on this graph, we're looking when a is equal to 2. So we're looking at that value. Well, as I'm coming in from the right-hand side, so that means a little bit bigger than 2. On the right-hand side, this is the part of the function I would touch. What is that value close to? It is close to 2. But if I come in from x on the left-hand side, meaning a little bit less than 2, I go up here to this part of the function, and what are we getting close to is 3. Now, when those two numbers are different, as in this case, and they ask you what is the limit as x approaches a, meaning from the right and the left, this limit does not exist. The only way it would exist is if these two numbers are the same. In fact, if we were to go look at our technique that we did from section 2.4, and I just would have asked you what is the limit as x approaches a, well, we could see, well, a little bit bigger than 2, we're here, a little bit less than 2, we're here. Those are not the same values, and that's why that limit does not exist. All right, let's look at this one. We have the limit as x approaches -1 from the right-hand side, and we want the limit as x approaches -1 from the left-hand side. All right, so again, the book has drawn us a little line at -1. Okay, so from the right-hand side, meaning to the right of -1, a little bit bigger than -1, where would we be? Well, we're exactly at 2. And if we go from the left-hand side, a little bit less than -1, we come way up here, and it looks like that would just keep going forever. And so positive infinity, or really that limit, does not exist. And so if I ask what is the limit as x approaches just -1, because these don't match, does not exist. Next one, we want the limit as x approaches 0 from the right-hand side. All right, so again, I look, here's 0. I want to go a little bit bigger than 0. What is my y value getting close to? 2. Then we have as x approaches 0 from the left-hand side, a little bit left of 0. And I'd have to come down here to this part of the function, and that's -2. And so if I ask you what is the limit as x approaches 0, does not exist, because again, those don't match. So you've got to really get used to that notation with the little pluses and little minuses to the right of the number. It's kind of really odd looking. All right, so again, we've got a is 1. So I want to go a little bit to the right of 1. I'd go up here. That's close to 2. To the left of 1, man, that's like right at 0. And I would say the limit as x approaches 1 does not exist. And I think they're giving you all of these examples about does not exist. I'm thinking at some point it would exist. Let's see if we can look at this graph. All right, let's see, what kind of problems could I ask you? Well, what if I ask you, what is the limit as x approaches 0 from the right-hand side? The limit as x approaches 0 from the left-hand side. And what is the limit as x just approaches 0? Okay, so same technique. Go to the right of 0, go to the left of 0, get really, really close. What does it look like the y value is getting closer to? Well, to me, that looks like it's close to 0. That looks like it's close to 0. So the limit must be 0. All right. Right. What if I ask you about the limit as x approaches 2 from the right or 2 from the left? Okay, so again, I'm going to go a little bit to the right of 2, go a little bit to the left of 2. Well, that y value looks the same. Looks like a 1 here, a 1 here. So again, I could say the limit as x approaches 2 is 1. Let me throw in another question. What is f of 2? When x is exactly 2, is y equal to 1? No, it hops up here and it equals to 2. So as you look at these pictures, think about left, right, things like that. And just to conclude, the limit as x approaches a single value, notice no plus, no minus, no right, no left, the limit exists if and only if the one from the right equals the one from the left. All right, so how do we do this if we don't have a graph? Well, pretty much just like we did in section 2.4, we're going to substitute the given value of x into the function. If we get that indeterminate form, then we're going to have to factor and reduce. All right, so just to kind of pick some problems, if I have the limit as x approaches 2 from the left, right? Now what they're trying to confuse you with that little minus sign is they're trying to make you think it's a negative 2, but it's not. It's a positive 2. So again, we're just going to put that value of x, that value in for x. So if I have 2 minus 3 over 2 plus 2, negative 1 over 4, and you're done. All right? Doesn't matter right or left. Let's look at another one. Let's say I have the limit as x approaches 3 from the right-hand side, and I have 4 times the square root of x minus 3. Now, you really couldn't have a limit as x approaches 3 from the left. Think about what kind of numbers are to the left of 3, like 2.9, 2.8. And if I plugged in like 2.9 or 2.8 in for x and I subtracted 3, I'd get negative. Square root of a negative is imaginary. All right, so that wouldn't be good. But since I'm talking about 3 from the right-hand side, again, if I just plug in 3, I'm going to get 0, and that is fine. All right. Let's say I have the limit as x approaches 5 from the left, and I have x squared minus 25 over x minus 5. Well, let's see, if I just plug in my number, 5 squared minus 25 over 5 minus 5, I get 0 over 0, and that is that indeterminate form. So what can I do? Well, I can factor the top. And the bottom is already factored. And I can reduce. And so then I can say, all right, the limit as x approaches 5 from the left of x plus 5. Again, just plugging in 5 for x, I get 10. Okay, so very much the same way, exactly the same way as we did the limits in section 2.4.